One feature that I would like to add to my game is to have the camera follow the ball wherever it goes. Right now, if I play the game and if I move my arrows, you can see that the ball moves up and down, left and right, but the camera is not following it. So let me stop the game, and this is not the right way to do it. But you might think, let's try this. Let's take the main camera and let's have it become a child of the player. And so I'm going to move it right on top of it. That way, maybe it's going to follow the player around because the main camera is tethered to it. It's a child of it. Let's see what happens. So let me play the game. All right, so let's see what happens when I press the up arrow. Whoa! Okay, so it is following the ball as I move as I press the up, down, left, and right arrow, but it is literally tied. Let me stop this. The camera is tied to that particular point in the sphere. Let me select the player. Let me press F. The camera, let's say it's over here. It's boom. Imagine there's a dot right here on that ball. As this ball rolls, you know that that dot is going to roll, and the camera is following that dot. That's why it's spinning. The camera is spinning along with a spinning ball. So this was not the right approach. Let me take that camera and let me drag and drop it outside. Let me put it back on the top here. That's kind of an interesting effect, right? That's something you maybe want to play around with, but that's not what we want to do. We want to follow the player, but we don't necessarily want to roll with the player as it moves around on our game. The approach that we're going to take is to create a script for this main camera to follow the player. Alright, so go ahead and make sure that main camera is selected. And then over here where you see the inspector on the very bottom, you'll see it says add component. We're going to click on this add component. Scroll all the way to the bottom, you'll see new script. And we're going to call this camera controller. Go ahead and click create and add. And now we're going to type the code such that the camera follows the player around. So let me switch back over here. Well, actually, let me go back over here because I think I did not put the script in the right location. I want the script to be in scripts. Let me select assets. Yep, sure enough, there's the camera controller. So I'll take this guy and drag it and drop it on top of scripts. So what I did was I selected assets. I found the script. I dragged it and dropped it on top of scripts, and there it is. Okay, so if I double click on camera controller, that should take me to Visual Studio Community, and here's the script. It's ready for me to type in some additional code. Alright, so with camera controller selected, I want you to place your cursor up here. Go ahead and tap. Let me press enter a couple times and I'll move my cursor back over here. Let's create two variables. The first one is going to be public. It's going to be a type game object. We'll call this player. Press enter. Now go ahead and type in private, and we're going to create a vector3, and we're going to call that offset. Here's my idea. Let me go back over here to Unity. The idea is this. Okay, so here I am in my scene view. Let me zoom out. The distance between the camera and the player, I need to know what that is. So imagine a line that's being drawn from the camera to the sphere or the player. Well, that is a line that's being drawn in 3D space. So if I look at it from this perspective or from this perspective or whatever the perspective I'm looking at it from, you can see that there is an invisible line that's connecting these two, and I want that line to always be maintained. This is the perspective, or this is the orientation of the camera relative to the ball. It's going to be it looks like it's a little bit up, a little bit back, maybe it's a little bit to the west or to the east. You know, this is the distance right here. And so that's what I'm doing over here by creating a vector3. This offset is really an invisible line in 3D space. This line has an x-axis, y-axis, z-axis, and so that vector3 is going to help me determine what that offset is. The player, eventually, this is going to be a reference here in code, but it's going to really be a reference to this guy right here. That ball, that is going to be my player in the code, so I know how to move the camera relative to the player. let me describe by typing in a comment. You don't have to do this. To illustrate what I'm trying to do, let's say that I'm located here in 3D space. Here's my player in 3D space. Here's the camera in 3D space. Well, I am going to get this distance, which is where am I relative to the camera? What is this distance? I'm also going to get this distance over here. Where am I relative to where the player is? Once I have that, if I have this distance, and if I subtract this distance, then I know what the distance is, if I subtract those two, from the camera to the player. And that's what I'm trying to maintain. Okay, let's get rid of this little graphic and replace that instead with code. Specifically, what I'm going to do is assign something to offset. What I'm going to do is I'm going to say transform dot position minus player dot transform dot position. All right, what does this mean? Remember, this code is associated with the camera. So we are affecting the camera. I need to know what the distance is. Let me go back over here. I need to know what that distance is from the camera to the player, or that sphere. And so what I need to do is, first of all, what is the distance of the camera? Right? This is the transform position of the camera, because that's the code that's being associated right now is to the camera. All right, so what is the distance from the origin to the camera? That's going to be a big distance, right? That's going to be a big distance. Now, subtract the player position, wherever that happens to be, and so we type in player.transform.position. So where is the player relative to the origin? So here's the player right here, really, really, really close to the origin. If I take those two and subtract, then I have this distance right here from the camera to the player, and that is going to be assigned to the variable offset. The next thing to do is to click over here inside of the update function, and we're going to type transform.position. What are we going to assign to this? We're going to type in player.transform.position, and we are going to add offset, semicolon. All right, so what are we doing here? I want to make sure that I'm always maintaining the distance from the camera to the player. All right, so I've established it at the beginning of the program, but I want to maintain that distance at all times as the player is moving around the game board. So what do? I say, okay, so first of all, where is the player located, right? So that ball right there, that's my player. Where are you located? All I have to do is add offset, because remember what offset is. Offset is a line. It's a vector 3, a line in 3D space with a specific direction and a specific magnitude, a specific length. It is the distance from here, the player, to the camera at a certain X, Y, and Z axis angle. It is that perfect line between those two. So now I know, hey, wherever the player is, plus the offset, that's where the camera is supposed to go. Remember, transform in this context is affecting the camera, because that's what we did. We are assigning, as you'll see over here, when I selected the camera, oh, this camera has a code that's associated with it. See, if I click this player, I don't see a code, that's called camera controller associated with this. I see a player controller script, but only for this camera is there a code called camera controller. And that camera controller script is referencing this specific camera. So transform position, we are talking about the position of the camera. Where do you want me to move the camera? Well, wherever the player is, plus this offset line, that's where I want you to move the camera. And I want you to keep on updating this so that every time that ball moves, or if it's sitting still, we're always making sure that this distance is always going to be maintained. And that's the purpose of this code, or this particular statement. Our code looks good, but I want you to make a slight modification. I just mentioned that update is called once per frame. What I want you to do is to type in the word late. Now this is a special function. It's still going to update, but what late update does is it performs this calculation, and then after the calculation has been performed, then we will execute the code. So the late update is going to wait and make sure that the calculations are done first before updating. So once I have that, don't forget to save. File, save. Looks good. Let's go back over here. Let's run the game and let's see what happens. Give it a couple seconds. We're going to go into the game mode. Here we are. So I'm going to press the down arrow. Wait a minute, what's going on? Press up, down, left, right. Nothing is happening. So let me stop the game and let's see what we have to work on. Well, the thing that I'm going to have to do is to make sure that I select main camera, and you'll notice over here that I have this item over here that says player. This is the player that I generated over here, the public variable player. When you create a public variable, what that's going to do is inside of our inspector, it's going to list that as one of our properties. So right now it's empty. What I need to do is I need to take this player, which refers to the sphere. I need to click, drag, and drop that and put it right on top of player. Now that I've done that, I can go ahead and run the game, and now let's see what happens. Okay, so as you can see, now the camera moves with the player, so I'm pressing the up, down, left, right arrows, and you can see that the camera is going to follow the player no matter where it goes. The next thing to work on is to make it so that when the player makes contact with any of the pickups, that the pickups disappear. And the way that we're going to do that is via code. Now, you'll recall that for player, we did already create a player script. There it is, player controller. And so that's already in Visual Studio. So I'm going to scroll back over here, or switch over to Visual Studio, and we're going to modify the code for the player controller script. By the way, I think if I were to, let's see, here's player controller script. I think if I click that gear, and here it is, edit script. If I click edit script, it should take me also straight to Visual Studio Community so that I can start modifying the script. Well, the first thing I'm going to want you to do is to press, or I should say click right here on the curly bracket just after the fixed update. Press enter a couple of times, because what I'm going to want you to do is to type exactly the following function name: on trigger enter. There it is. Let me double click it. Now, when I double clicked it, wow, that's kind of nice. It looks like it put in parens collider other. That's the argument that I'm going to be sending to this on trigger enter, and I'm going to be typing the following code. Now, I'm not explaining the code right now. I'm just wanting you to type it in, and then I'll explain it in just a moment. Other.gameObject.compare tag, and then parens, we're going to type in pickup, just like that. And then we're going to put our curly braces right here for the if statement. You're going to type in other.gameObject.setActive, and we'll say false. And then don't forget the semicolon at the end. First of all, this is a special function. When a triggered has occurred, that's what this means. On trigger enter means when a trigger has occurred. Oh, and by the way, what was the trigger with? Well, remember, we are generating code for player. Player is our sphere. So this is the code directly that's relevant to the sphere, or to our player. And so we're saying, hey, when we have detected that our sphere, or our player, has triggered, has entered into a trigger type of event, when that has happened, I'm going to tell you this is what it happened with. This is what it triggered with. Oh, and by the way, if that trigger happens to have a tag called pickup, then I want you to make it so that it's active, set active is set to false. In other words, if I were to select that sphere right there, actually if I select this cube right here, and if I were to click this guy right here, you can see it disappears. Active appears. Not active disappears. So what we're going to do is we're going to change the tags for all of these pickups to pickup. When our sphere, or our player, collides with one of those pickups, and that's what this if statement says, when it collides with an object, if that object happens to have a tag called pickup, then make it disappear. Or in other words, make the setActive property set to false. All right, well, before I proceed, let me make sure that I save my work. So I'm going to click on File, then I'll click on Save, and then I'm going to switch back over here to Unity. And let's see here. Let me select the prefabs folder from the Project tab. Select prefabs, and I'm going to select Pickup. And you'll notice that I have a tag item over here in the inspector. It says tag untagged. Well, let's see what happens if I click that drop down. I can give this a tag. I can give all of my pickups a tag. I can call it respawn, finish, blah, 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 blah. Nope, I don't want that. I want specifically a tag called pickup to be associated with those cubes. So let me select that. I'm going to go over here and I'm going to say add tag. There it is. The list is empty. Let me click this plus symbol right here and I'll type in very carefully pickup with capital U. Uh-oh, that wasn't so careful. There we go. Pickup, just like this, capital P, capital U, and we'll click Save. Well, now that I've generated that tag, I want to associate the tag with this, with the pickup. So I'm going to select this guy again, and then where it says tag, I'm going to click the drop down, and there's pickup. So I'm going to click this guy over here, and so now that tag pickup is associated with my prefab called pickup. So let's see what happens. So I'm going to click this guy over here, and look at that. It has a tag that says pickup. I'm going to select this guy over here, and look at that. It has a tag called pickup, and that's the beauty of prefabs. Remember, we have designed this class. We've designed this this entity, right? This abstract called pickup, and then I made it come to reality, or I instantiated it by copying and pasting 12 of these. So these are the children, and this is the parent. The pickup is basically an idea of a cube that's yellow, that rotates a certain way. Oh, and now, by the way, it's going to be called pickup in terms of its tag. And so when I affect this, it affects all the children. Isn't that nice? Okay, so now what I'm saying is, hey, player, I've just generated a script for you such that when you collide with something, that something that you just collided with, if it has a tag called pickup, which all of these guys do, then hey, I want you to change the setActive state to false. All right, I think I saved this already. Yeah, I did. All right, let's go back and let's see what happens. So let's go into the game mode by playing it, and I'm going to use the arrows and, oh, wait a minute, what happened? So I'm bouncing, wait a minute, you're supposed to disappear. What's going on? Okay, so let's get out of the gameplay mode. At this point, what I'll need you to do is to select the prefabs folder, select the pickup prefab, and you'll notice over here where it says box collider, is trigger is not checked. We definitely want to check that item, because what we're doing is we're saying, in terms of a collision, yeah, you're allowing this thing to be triggerable. In other words, yeah, I need you to be able to detect when there is a trigger of some item against this particular pickup object. So now that I've applied it to the prefab, that means it has applied it to all of the children, namely all these objects that I've placed which are based on this prefab called pickup. All of those are now triggerable as a result of clicking this. Let me save my work. I don't think I've done that yet. So File, and let's say Save Project, and let's go ahead and run the game. So I'll click over here, play. All right, so now if I move my up, down, left, right arrows, nice. So notice that when it makes contact with the various items, and right now I'm just pressing the arrows on my keyboard to try to make contact with all of these guys, and oh, I almost got that one. Ugh, okay, I'm doing the thing where I'm overcompensating here, so let me just get really closely. Bam, nice. So now when I make contact, when the ball or the player makes contact with any of these items, or any item that is called pickup, then it's going to change the setActive state to false. Notice that this does not make the walls disappear. So let me play the game again. And if I collide with a wall, it doesn't disappear, right? Because this thing does not have a tag called set active. Now, if I wanted to, I could click west wall, any of these walls, right? Right now they're untagged. If I gave it the tag pickup, well then guess what would happen? The walls would disappear. And if you want to play around with that, go ahead. If the ball or if the player makes contact with a wall that has a tag called pickup, that thing's going to disappear, and we don't want that. We only want to apply that to the pickups. Okay, the last thing to consider is not so intuitive. It's something that happens in memory within Unity, and that is the following. So first of all, these walls right here that we've entered, that information is entered into static memory. And the more items that we have that are entered into static memory, that's going to make our game not so efficient. Now, right now, if I run the program, and my laptop is, gosh, I don't know what, 4 or 5 years old, everything looks pretty good. It looks like the cubes are rotating nicely. I don't see any type of skipping or anything like that. In fact, let's see here. One of the modes, I could change how this thing is run. Let's see, is it over here? Yeah, when I play this thing, it says maximize on play, yep, and I want to see stats. Okay, so when I maximize on play and stats, let's see, if I stop playing, and then if I hit play again, it should maximize the screen. Ah, nice. Okay, so this is a pretty big screen. On my old laptop, everything is looking pretty good. I mean, there's no skipping or anything like that taking place. In fact, it looks like I'm currently seeing the graphics at 80, what looks like about 80 something to 90 something frames per second. That's actually pretty good. I mean, for an old laptop to be able to do this, it looks like you can see all the other features here in terms of what your game is doing, how much resources it's taking, what CPU power it's taking, so forth and so on. Okay, so I'll take off stats, I'll take off maximize on play, and I'll stop this, and we'll go back over here. So when you drag and drop things like this, these are static items. They are saved in memory. They're taking up resources. Now for our little game, no big deal. These guys over here, they are also static. They are taking up resources. But as your game gets more and more sophisticated, you're not going to want that. You don't want to take up all of this information on static memory. You want to have it saved in dynamic memory, which means that if it's using it, fine, let's occupy memory. If we're not using it, then get rid of it right now because we're not using it. But later on, we can occupy memory to get information about any one of these particular objects. So, in other words, we're talking about making your games more efficient. Because if we're running it on a laptop, no problem. But what if you're running this on a mobile device with limited resources? Well, then efficiency becomes an issue. Okay, so what I want you to do is you'll select prefabs, you'll select pickup, and the way to make these guys move from static to dynamic memory is basically to make them rigid bodies. So what we're going to do is we're going to scroll all the way to the bottom. Again, you have pickup selected, and we're going to say add component, and I believe that's in physics, so I'm going to click on physics, and we're going to look for the term rigid body. There it is, rigid body. So you select rigid body, and then you're going to see the following components. Okay, so by making these guys rigid bodies, now this is going to be dealt with, this information, the items that you create are going to be dealt with in dynamic memory, and so it's going to make your game more efficient. It only saves the information of those items as they are being used. Okay, but here's a problem. Okay, it says use gravity. It's checked. Let's see what happens when I play the game. So I start the game, and what happens? Did you see that? How those cubes? Well, now they are affected by gravity because you're saying, hey, these are rigid bodies. And I'm saying that I want them to be affected by gravity. So when I start the game, gravity is pulling down on these pickups because they're rigid bodies now, and they go out of existence. What I could do is I could say, okay, let's take off gravity, but that's not what I want to do. What I want to do is I want to select is kinematic. So what is kinematic says is, first of all, these, even though this is a rigid body, I don't want you to be affected by gravity. I don't want you to be affected by physics. Now, you still have a collider. You have the ability to receive collisions from other items. So when this ball or when the player interacts with you, yeah, you can, that's okay. We'll take that interaction. But in terms of physics, you are not going to be affected by physics. So in other words, we're creating a rigid body that is not affected by physics. So let's see what happens now when I click play. Okay, so gravity did not pull them down. It looks like they're still transforming. They're still rotating. And let's see what happens in terms of the interaction. So now I'm going to use the up, down, left, right arrows, and if I interact with them, perfect. So they are still triggered when the player makes contact with them, and gravity is not having an effect on them. And now, because of that little change, there's something that's happening underneath the hood. We are not taking up static memory. We are using dynamic memory. In other words, what you're doing is you're making your program more efficient. Yes, we have to store information like this, and also the plane. That's going to be in static memory, but who cares? Those just a limited number of items. In fact, really, who cares about static memory for these guys? But as you go from dozens and dozens and hundreds of objects, then all of a sudden, memory efficiency becomes more important. So I'm just letting you know in the get-go, if you want to consider making your games more efficient and not have all of this information stored in static memory and only stored in memory when it's in use, then you're going to make those items rigid bodies, and then we want them to perhaps not be affected by physics. Well, that's what this is kinematic means. With this, yeah, physics can affect me. If I strike you, I can push you. But, or maybe if you're in an immovable force like this wall, if I roll up against you, then I'm bumping up against you and I can't move. But with this guy, what you're saying is you are not affected by physics. So that's why with gravity selected on or off, it didn't matter, because I'm not going to be affected by gravity, because you're saying I'm not even affected by gravity by saying is kinematic. Yeah, I am affected by triggering, but gravity has, or sorry, physics has no effect on me. And that's it.